Hello everyone. Welcome to my presentation entitled Beyond Continuous Integration Testing with Artificial Intelligence, which can be considered as the new wave of test automation at industry. My name is Sahar Tahvili. I am a senior data scientist at Global AI Accelerator at Ericsson. We have this group here in Sweden, in India, in Canada, and also North America. At Ericsson, we are trying to use more and more AI solutions for improving the quality and service portfolio, and also we are working on innovation and designing and prototyping new AI-based solutions. I have background in applied mathematics and also got my PhD in software testing with the focus of test optimization and using and employing AI technology for improving software testing process. Today I'm going to talk about two main topics. First, why AI, why we should use AI and why AI is very popular today and how we can employ the AI technologies for improving the testing process and final product, time minimization and optimizing the testing process. Secondly, I'm going to cover the mentioned topic by two industrial case studies conducted at Ericsson in the telecom domain. When we are talking about AI and software testing, we are actually talking about two different topics. First, testing AI applications, and secondly, using AI for software testing. As soon as we are designing a new model, new AI solution, we need to test the model before we release the model or even before we use the model in the final product for optimization purposes or any other purposes at industry. Secondly is using existing AI solutions for improving the testing process and the final quality of the product. In this presentation, I'm mostly talking about the second part, which is AI for software testing. If we are reviewing the history of software testing in early 80s, software testing became as a new independent topic in the software engineering, and that time the testing just performed manually, 100% manually. But during the time from 80s until now, at industries and even at academia, people try to automate this process, employing different models and minimizing the human work. Still, manual testing can be considered as a critical and very important testing procedure at industry, especially in the safety critical systems. So many researchers claim that software testing, if software testing performed manually, they are able to detect more bug in the system, and in the safety critical system is recommended sometimes to use manual testing instead for fully automated or semi-automated version of the testing. But of course, manual testing has some disadvantages. It takes time, it's human dependent, and at industry, usually we go for automation. But should we sacrifice the quality of the product because of automation? Or should we keep human working manually just because we want to be sure before we release the product to the market? And how we can measure the trade-off between these two? Should we go for this scenario or that scenario, or there is a bridge between these two that still we can use human judgment, human knowledge and skills in the testing, and still we can go for automation? According to the news, up to 70% of the software testing can be performed by AI today. And more than 64% of the company in the world, they want to go for the AI just because they can increase the quality of the product, and they can decrease, of course, the cost and human work. At Ericsson, when we design AI solution and when we are trying to apply AI solution, we use a model. And I'm trying in this figure to show how this model works, and this is adapted based on the case studies that I'm going to present later in this presentation. So as soon as we get a request from different departments at Ericsson, we are starting with the pre-study phase, which means we are not just searching for any AI solution which exists today in the state of the art or at industry. Sometimes we are trying to design a new solution, and sometimes we are measuring this trade-off. Is good enough to go for AI, or is a manual version of the testing is good enough? So what we should do in this scenario? So we are trying to find answers for both questions. Then we go for the checking for the data availability. We are not able to use AI and machine learning without any available data, which is not case in Ericsson just because we have our own data, and as soon as we are designing a new algorithm, we have this chance to test our algorithm before using the algorithm or releasing the algorithm as open source. But but there is some solutions. If the data is not available, you can buy the data, or you can generate the data, or you can use other solutions. But I'm not going to talk about that part because it's not case in the case studies that I'm going to present later. So as soon as the data is available and we measure the trade-off, the return on investment, and we find a solution or we design a new AI solution, then we can start like other AI procedure. Then we gather the data, we clean the data, we normalize the data, we work with feature extraction, data transformation. Everything is similar like any other AI proposed solution procedure. The second problem that we are facing most of the time is the evaluation of the model. It's not enough if you have just the data. You need to evaluate the performance of the algorithm, as you know. So if there's no ground truth, if we have no ground truth, how we can evaluate the model? Sometimes we have this ground truth, sometimes we don't have it, sometimes we generate the ground truth from the machines. And most of the time, especially in the manual testing, we are using the tester's knowledge and skills for evaluation. We are hiding the results and we're sending a survey to them and we are asking this scenario. We have a plan to classify test cases based on their similarities or dependencies. We have a model, we are able to find these results, but we remove the results and we are asking them, can you classify test cases based on several factors, several criteria, using your own knowledge, your skills? So how you can classify test cases? They label data, and we use sometimes this label data for evaluating the performance of the model. And as soon as we have the label data, then we have more chance to use more different AI solutions. So we can go for supervised solutions as well. I'm going to later cover this part with the mentioned case studies that how we evaluate the model by using their knowledge. But why AI is applicable in software testing? One answer is just most of the testing artifacts are written in natural text. Sometimes they are written by human in natural text, like requirements specifications, test specifications, and sometimes it's generated from machine, like a log report, but it still is written in natural text. So having an AI-based decision support system can help us to understand and analyze better the testing artifacts. That's why we are using most of the time natural language processing techniques to get a better overview about the testing artifacts. Based on several criteria, we can analyze them, we can cluster them, we can classify them, we can go for a faster and more accurate troubleshooting by having a good idea and overview about the failure reasons which are written in natural text. Most of the time, we are using AI technology for test optimization purposes. Just because we are trying to minimize the time, increasing the quality. So it could be applied in different fields like test case selection, prioritization, scheduling, minimization. If you have a plan to reduce some test cases from the testing cycle. Even for test script generation, the input is test specification, and usually testers, they are reading this test specification and they know which command in C# or Java is corresponding to this test activity, but this process can be automated as well. And execution time prediction, all regression analysis techniques can be applied here as well. So test optimization usually is the keyword here when we are talking about AI and software testing. Today in the testing process, most of the decisions are made by human. And it requires human judgment, human knowledge, human skills. And our plan is to work more with the testers and helping the algorithm to learn more and more from the testers and test engineers at Ericsson. How we can capture this information for decision making. What they want to do when they face a new problem, for instance, in test troubleshooting activity. They read a log report and they do activity based on the failure, which is documented in the log report. If we can extract this activity, then we can learn the machine, the algorithm, to do a correct troubleshooting activity based on the failure. So we are working most of the time with the interactions between the testers, test engineers, and also the algorithms that sometimes we are designing, sometimes we are working with the existing algorithms. So the final goal is most of the time designing different decision support systems for different purposes like troubleshooting activity or test scheduling by using human knowledge. Vectorization can be considered as one solution for using AI algorithms in software testing. As soon as we can make a vector, we can create a vector for a testing artifact, then we can apply different optimization techniques. So as I said before, most of the testing artifacts that we are working are written in natural text, but the model that I'm going to present is not limited just to the natural text, and it can be used even for Java and C# test scripts. And we are trying to make a vector for each test artifact, for each test case or log report or test specification, requirements and specification. We are going to generate a vector by using deep neural networks model. In case study 1, I am going to talk about parallel test execution. Usually there are two different ways for testing the product: parallel test execution or serial test execution. In a serial test execution, all designed test cases, for instance, for testing product 1, should be executed after each other. And when you are done for execution of product 1, then you can start to execute test cases for product 2. There is another solution, which is parallel test execution for those test cases which are designed for testing those 5 products, but they are similar or they have overlap with each other. But you need to know what is the similarities and how much overlap we have between those test cases. But why parallel test execution is a good solution? Just because you can minimize the time. But before we go for time minimization, we should consider that the total time for executing a test case is the sum of two different factors. First is the system setup time or installation, the time that you need to prepare the system, the testing environment for testing before you go for actual testing, before you execute test activities. So we use TSJ for this one. And the second one, TAJ, is the activity time that you need to execute a test case. And they are different. It depends on the functionality that you are going to test. If it's automated test, is the line of the code, the number of line of the code. If it's a manual test execution, it depends on how many pages you have, and is another type of time. In the parallel test execution, in this problem, in this case study, we are trying to minimize the first parameter, TCGA, the time that you need to prepare the system for execution for each test case. Then the saving time will be the number of product that you are going to test, -1, divide to the number of product times 100 if you want to have it as a percentage. It means you are going to do this system setup once, and all test cases which are required same system setup and same installation will be executed after each other. So that is our definition for parallel test execution. Assume you have more than 1,000 test cases for testing those 5 products in this figure, and there is overlap or similarities between those test cases just for the first factor, for the time system setups time. We try to divide test cases based on their similarities in 4 main groups: identical test cases, similar, very similar, and partially similar test cases. We got this information from the testers and test engineers at Ericsson, and they said they can divide it in 4 groups based on this information. Then we propose a new solution, and we use edit distance method for the first phase, dividing test cases in 4 groups using natural language processing, edit distance for dividing test cases, classifying test cases based on their similarities in these 4 mentioned groups. Another solution is neural network. You have test cases written in natural language text as input, then you can use a SPERT or Doc2Vec or any other algorithms which are able to analyze the test specification, and then you can get a output as a high dimensional vectors that we try to reduce the dimensionality, and we use TSNE here to just show the figures. So we cluster test cases based on the similarity. Each circle here in both figures shows a cluster of test cases which are similar to each other. Another solution is cluster-based execution. You can execute those test cases which are similar to each other at the same time. The potential saving cost and time by using parallel test execution based on the similarities between test cases, and I'm just talking about system setup time for each test case, is presented in that table. As I said before, you do system setup once and you execute all test cases which are required same system setup, installation effort, and pre-setup. In the case study 2, we try to minimize the number of tests inside of the test suite reduction. But in this case, the input is Java code, test script written in Java code. But we propose almost the same solution. A deep neural network for code analysis, and the output is high dimensional vectors. The proposed solution in this case does a synthetic analysis on the code level, and we are able to cluster test cases based on their similarity again, and we are able also to predict the properties of the code, the main part of the code, the main function of the code. This time we use code-to-vec, another deep learning approach, which is a neural network for learning distributed representations of the code. And similarity here in this case is a little bit different with the similarity in the first case study. Similarity in this case means two test cases are similar if they have at least one shared function. If they are designed to test at least same functionality, at least one same functionality, then we consider them as a similar test cases. The input of this problem is test script. In this case, they're written in Java code. Then we use deep neural network, code-to-vec algorithm, and the output is high dimensional data points, as you can see in this figure. So we use different test scripts. We train the model, we use a pre-trained model, and the output is a high dimensional vectors that we try to cluster them based on their similarities. Here we can see what we got as output. In this table, we see the test case names and the main functionality for each test case, and we can see how we cluster them with each other. As you can see in the table, those test cases which are clustered together, if they have the same number, it means they are ended up in the same cluster. They have at least one same functionality with each other, which means they are designed to test the same functionality. But if we are checking the test case names, it's not easy to understand that they are designed sometimes to test the same functionality. So now that is the question. Is a good solution if you execute all test cases which are designed to test same functionality, or is it enough to get just a sample from each cluster for execution if you have a plan for reduction, if you don't have enough time to execute all test cases? So maybe one sample from each cluster is good enough for execution. And in this figure, we can see how many clusters we got and how we cluster test cases with each other. And the empirical evaluation shows around 25% of test cases which are designed for testing one product are similar. So it's a good value that shows that we can start our reduction in that part. We don't need to execute all of them. Of course, how many percentage or how many test cases from each cluster should be executed, we need to check other criteria as well. Execution time, requirement coverage, line of the code, and other criteria. But we are just talking about the similarities, how test cases can be reduced by similarities, how we can minimize the time based on similarities. And in the case study 2, the similarity means the same functionality for each test case. So that's all for me. So here is my email address, and please contact me if you have any more questions about presented case studies and the methods that we are using. And thank you very much.